our big goal with this lesson is we want you to be able to calculate and predict what are going to be the dimensions of the different parts for your project. Because if you think about it, if we're going to go in the workshop and we're going to start cutting up pieces of wood, well, we need to know the exact dimensions of those pieces of wood. And so things fit together properly and there's no weird gaps or anything like that. And we don't want to get stuck in the workshop with different problems and things not fitting. We want to avoid that as much as possible. And we don't want to waste supplies. So this is important to calculate this so then we also don't waste supplies. Now, this isn't necessarily going to apply to every single person's project. So if you're 3D printing something, if you're making something out of, let's say, PVC pipe or whatever, this isn't going to exactly match up, but this is still basic important information that I want you to know so you can be successful here continuing on in the middle school with our design type projects. And then just beyond the middle school too, it's just good information to understand. We're going to be thinking of it like a simple box. So imagine we have a simple box. How many parts are to that box? Just pretend it's 6 by 6 by 6. How many different parts would that enclosed box be made out of? Hopefully you were thinking that that box is made out of 6 parts because you got a top and bottom, front and back, and then your 2 sides. So that together equals 6 different parts. So if you're thinking about that, well, okay, well what should the size of each part be? If we want the outside dimensions of the box to be 6 by 6 by 6, what should be the size of each piece? So for example here I have 6 pieces of wood that are all 6 inches by 6 inches. I know you can't see that the best here. It's not that important right now, but anyway. So it's kind of like, okay, what some people do is they start thinking, okay, if I want a box that's 6 by 6 by 6, that means I'm going to cut every single piece to be exactly the same size, to be 6 inches by 6 inches by 6 inches. So then they do that, and then they start putting it together, and then they realize that that actually doesn't work. And I'm going to prove it to you. For example, let's pretend this is the bottom, and then I put a side here. So just this bottom piece here, this is 6 inches wide. This is 6 inches. So if I put a piece to the outside of it, well, this piece has thickness. This side piece has thickness. This wood is 3/4 inches thick. So now this is wider than 6 inches. This is no longer a 6-inch box on the outside. This is now 6 plus the thickness, which is 0.75, 3/4 of an inch. That would be 6 3/4. Well, now, if I have 2 sides, now I'm definitely way over 6 inches long. So now we would do 3/4 inch plus 3/4 inch equals 1.5. 1.5 inches plus 6 inches now is 7.5. So this box now is 7.5. So that should tell us, well, we got to do something. You know, something's not right here. I can't just have all 6-inch pieces because it's not going to make me, let's say, a perfect cube on the outside. There's going to be issues here. On Canvas, there is a link to this calculating piece size practice. So at this point, I'm going to want you to pause here and bring this document up. Notice we're going to fill in some things on the table or the chart here. And notice there's also a link. That link is going to take us to this technical drawing, which is this. So I need you to pause here, get this document open right now. It should be on Canvas. And get this stuff open because we're going to start looking at it. Go. We're going to look at that technical drawing in a second. And what I want you to answer or think about is how many unique pieces is that box made out of? How many unique pieces? We know that box can be made out of 6 total pieces, but how many of those pieces are unique? And then just let's review real quick these words here. So height, of course, is how tall it is. Length is this distance, and then width is that distance. Let's try to understand this blueprint or this technical drawing. If we look at our isometric view, our 3D view, we can see that these pieces are actually labeled. Notice the top is resting on all the pieces. The top is resting on the sides and also the front and back. We can't see the back right now, but there is a back. The back exists. And then notice the bottom piece is between the sides and it's underneath the front and back. And notice the sides. The sides are below the top, but they're next to the bottom, and the side goes the full distance, goes the full width of this cube. And if we look at our different views here, so what view is this? So this is definitely the front view. So if this is the front view, what part is my mouse on right now? What view is this? What part of the box is my mouse on right now? So in this here, this would be the side view. What part is my mouse on now? So we're trying to figure out what is the size of the top piece, what's the size of the sides, what's the size of the bottom, what's the size of the front and back. Because imagine if we're going into the workshop and we're going to start cutting this box up, we would need to know all those different dimensions. We would need to know the quantities of each part as well. So let's figure out the size of the top piece first. So quantity of the top piece, well, there's only one top piece, so we can start filling that in. So follow along with me here. Do this on your document as well. So quantity is going to be 1. There's only one top piece. Length and height. Let's figure out the length and height of that top piece. And notice in our drawing here, it says we got 10 inches for length and 10 inches for height. And notice the top goes all the way across. The top is over all of it. So if the top goes all the way back, and if the top goes all the way from left to right, that means that that top piece must be 10 inches by 10 inches. So that answer I will just give you right there. So we say 10 inches by 10 inches, and the thickness. We're pretending for this situation, we're going to pretend that the wood is 0.5 inches thick. So now if you notice here, then this is a nice clean way that I know I can take this information in the workshop and cut that. So now let's jump down to the front and the back. On our drawing here, we can see that the front, it's sandwiched between the sides, and it's sandwiched between the top and bottom. So if we use logic, we think this through. Okay, well, this top piece has thickness, this bottom piece has thickness. So if the total height here is 10, but this front piece is sandwiched between a top and a bottom, and those have thickness, then the front piece must be less than 10. So if it helps you, I want to show you, I got that logic written out. If the box is 10 inches long and the front fits between the sides have thickness, then the front must be less than 10 inches wide, or I'm going to change that to long. Then the front must be less than 10 inches long. So here's how we can think about the math for this. If the box is 10 inches long and the front fits between two side pieces, and each side piece has a thickness of 0.5 inches, then we have to do one or two things. We have to multiply 0.5 times 2, or we can just add 0.5 plus 0.5. And we have to subtract that from our total distance, and here's why. So if we go back to our technical drawing, if this total distance is 10 inches, this little chunk, this little distance here is 0.5, this little distance is 0.5. We add up these three distances. Let's call this distance 1 plus distance 2, which is the whole front, plus distance 3 equals a total of 10. So we know that the total is 10. This is 0.5. This is 0.5. So our equation would be 0.5 plus 0.5, and we're going to subtract that from 10. So 0.5 plus 0.5 is a whole, meaning 1, and so then we do 10 minus 1 equals 9. So what that equation looks like is this. And you could, like I said, you can either multiply it times 2, do whatever works for your brain. 0.5 times 2 equals 1, or add it up together, and remember the 0.5, this 0.5 represents what? And then what does this 10 represent in this situation? So we take 10 minus 1, we get 9. That means that that front piece must be 9 inches wide then. And then the height of it would be the same exact thing. That's going to be 9 inches by 9 inches, and then the thickness is still the same. So let's take a look at the side piece. How many side pieces are there? Hopefully you said 2, because there's a left and a right. And then let's figure out the length and the height. So this distance from the very front of the side piece to the back of the side piece, what is that distance? Well, you said 10 inches because that's the total, we call that width of the cube. So that's there to there is 10 inches, and then the total, can this piece, in this situation, can the side piece be 10 inches tall? So the side piece cannot be 10 inches tall because part of it is cut off from the thickness of the top piece. The total height of this cube is 10 inches tall, but now we have to subtract 0.5. So 10 minus 0.5 is, so for our side piece, we're going to write that is 10 inches long, and it is 9.5 tall. And then of course it's 0.5 inches thick. The bottom, let's figure out the bottom. And then the width of the bottom piece is what? Now notice the bottom, here's the bottom in our side view. This is why we do multiple views. Notice it goes all the way from here to back. It's the whole distance. So for our bottom piece, fill in your table there. We're going to have one bottom piece. It doesn't matter too much to me what order you put these numbers in here, just as long as you have the numbers correct. So that would be, the numbers in your table should look something like, for scenario 1, we were imagining that the thickness of those pieces was 0.5 inches thick. So now in scenario 2, notice we're going to change this up a little bit. We're going to pretend that the thickness of each piece is 0.75 inches thick. That's the same as 3/4. So it's perfectly fine if you want to use a calculator. Your mission now is to determine what's the size, the quantity, length, height, the size, and thickness of all these different pieces. Refer back to this, your first chart. Refer back to your first table to, of course, help you out. You're doing the same exact math. It's just that these numbers the thickness is different. So try and calculate that, and then get some feedback from me. One thing I want you thinking about then, well, how can you apply this to your own project? What does this have to do with you and your own project? So we got our big full-page sketch here, and now notice that I would be adding, I have a bottom piece, and a back piece, and a top piece, like, depending on how these are set up. Now because of how I drew it, I can determine the thickness of the piece by choosing the appropriate wood or thickness of material. So if you're not sure what thickness of material you should use, you can of course ask me. But so for example, this top piece is sitting on this front piece. So then now I can start doing some math and totaling up these different distances to help me determine what size does each piece need to be. What we're eventually going to do is use this Parts 3D modeling plan, where what you'll do is you'll actually, before you start 3D modeling every single piece for your own project, is you're going to write down like the piece, the description, quantity, and the different sizes of those pieces. On our prototype, one reason why we didn't want to throw it away and crush it is what we wanted to actually do on it. Like it works great if we take a Sharpie or something that really stands out, is we can label every unique part and give it a letter. So let's say you're making a box, maybe the top and bottom are the same, so you label those A, and then the two sides are the same, so you label those B, and the front and back are the same, so you label those C, and actually write on there. And then we can write the actual dimensions on the prototype too, but there's just a lot of different things we can do to help keep us very organized. I hope this helped you to get started to think about how will you actually calculate the different sizes of parts for your project.